Good day, everyone. Today, I will discuss to you about the topic molarity. But before we dig into the discussion, let's have a brief explanation in its background. So, we all know that many environmental reactions and almost all biochemical reactions occur in solutions. Liquid solutions are easier to store than gases and easier to mix than solids, and the amount of substances can be measured precisely. We know the amount of pure substances by converting their masses into the number of moles. But for the dissolved substances or solution, we need the concentration, the number of moles of solute per liters of solution, to get the volume that a certain solution contains. So concentration expressed as the amount of solute being dissolved in a given quantity of solvent or quantity of solution. The greater the amount of solute being dissolved in a quantity of solvent, the more concentrated the solution is. So the common way to express a concentration is through molarity. So molarity expresses the concentration of a solution in units of moles per liter of solution. And it can mathematically write as molarity as moles of solute per liter of solution. So it means that in every 1 molar of solution, it contains 1 mole of solute per liter of solution. So to further understand, let's have a sample problem. We have a sample problem here. So calculate the molarity of a solution made by dissolving 23.4 grams of sodium sulfate in enough water to form 125 ml of solution. So we have our solute here, which is sodium sulfate that weigh 23.4 grams. And our liter volume of solution rather, is 125 ml. But as we can see that our solute is supposed to be in moles, but the given is in grams. So we need to convert it first before we can get the molarity. So 23.4 grams of sodium sulfate, or its chemical formula is Na2SO4 times in every 1 mole of Na2SO4. So to get its mass, we need to add So to get the weight of the Na2SO4 or the mass of Na2SO4, we need to add their atomic weight. So the atomic weight of Na is 23 times 2 because it has a 2 atoms of Na, so 46. For sulfur, we have 32. And for oxygen, we have 16. So to add up that together, we have 46. So we have 142 grams of Na2SO4. So it means that in every 1 mole of Na2SO4, it contains 142 grams of Na2SO4. So we have to cancel the grams. So we are left by moles. So have to multiply 23.4 times 1 divided into 142. So the answer is 0.165 mole of Na2SO4. So now we have the given solute in mole. And now for our volume, we know that our volume is in milliliters, so we have to convert that to liters. So 125 ml times, we know that in every liter, it contains 1000 ml. So we have to cancel the milliliters, so we're left by liters. So 125 times 1 divided by 1000. So we're left by 0.125 liter. So this is just a simple, very simple conversion factor that we have learned in our past senior high school days. So now that we have the given for the moles of solute, which is 0.165 mole of sodium sulfate, and the liter of solution is 0.125 liters, now we can calculate the molarity of the solution. So moles of solute is equal to 0.165 mole, and the liter of solution is 0.125 liter. So simple is we have to divide only. So the answer is 1.32 molar. So the unit of the molarity is molar, and it can be denoted by the big letter M. So our answer is in three significant figures because our given is in three significant figures also. So the final answer is 1.32 M. So we have another sample problem to further digest the topic. So calculate the molarity of a solution made by dissolving 1.515 grams of sulfuric acid in 1000 milliliter of solution. So as we can see that the given solute is in grams, so we have to convert that from grams into moles, and the volume of the solution is in milliliters, so we have to convert that to liter. So 1.515 grams of sulfuric acid times 1 mole of sulfuric acid is equal to 98 grams of H2SO4. So we get this 98 by adding the atomic weight of the sulfuric acid. So here is the calculation. So atomic weight of hydrogen is 1 times 2 atom of hydrogen is 2. Sulfuric acid, sulfur rather, is 32. Then the oxygen is 16 times 4 atoms of oxygen is equal to 64. Sum it up, it is equal to 98 grams of sulfuric acid. So by calculating this one, we are come up with the mole of solute, which is 0.01546 mole of sulfuric acid. So now we are going to convert the volume from milliliter to liter. So 1000 ml times 1 liter is equal to 1000 ml. So we divide that. So 1000 divided by 1000 is basically 1 liter. So now we have the given for the volume of the solution. So now we're going to like put on the this given value, so now we can get the molarity. So 0.01546 mole divided by 1 liter is equal to 0.01546 molar. So we have to divide this by 1, so the same answer. So now the unit of the molarity is denoted by big letter M and can be pronounced as molar. So the answer is 0.01546. So the answer is in 4 significant figures because the given is in 4 significant figures also. So I guess that was the wrap up of our discussion. I hope you have learned what the molarity is all about and how to calculate the molarity. So just practice solving for the molarity because it's very simple, and I hope you learned something from me. Thank you. Molarity expresses the concentration in units of moles of solute per liter of solution. Concentration is often expressed as the quantity of solute dissolved in a given quantity of solution. Solute is the substance that is being dissolved. Solvent is a liquid substance that is used to dissolve another substance.